I'm just going to list types of forces we're going to run into in the lab. Types of forces that we're going to run into in the lab and just in our problems that we're going to be solving. Well, the first one is, again, gravitational force. I just finished talking about that. So gravitational force. And we're going to use an FG. And when you think of that, think of an object's weight. An object's weight, force of gravity. Okay? My weight is the force of gravity, the Earth gravitationally pulling down on me. That's my weight, force of gravity. You can calculate this by multiplying an object's mass in kilograms times g, 9.8 meters per second squared, here at the surface of the Earth. Near the surface of the Earth, it's 9.8 meters per second squared. Be sure your mass is in kilograms. Will give you an object's weight in newtons. M times g, remember that? That's important. Weight, gravitational force, is M times g. G does not have a sign, so don't make it negative. Okay. Gravitational force. And that's it for gravitational force. It's the electromagnetic force that shows up differently in our everyday experience. For example, if I don't have a bunch of stuff in front of me. When I'm in the classroom, I'll show you this stuff. Hold on, I'll just show you one thing. Exciting physics demo. So if I pull on the string, all right, I create a little tension force in the string, just like in a guitar string or something, all right? Tension is electromagnetic. It is a version, it is a form of electromagnetic force. And so we see tension, and we're going to deal with tension as one of the forces in this class. We'll use an uppercase T. Sometimes you can use an F subscript T. I'll use an uppercase T for tension. Okay. Another type of electromagnetic force is one that you're all familiar with. We've been talking about any kind of drag force, which I usually use like an F drag, although there are different symbols, like sometimes I see an R for resistive force. But that's like air resistance. Any resistive force from a fluid. If you tried to go swimming in a vat of molasses, there'd be a lot of drag force acting on there, right? It's really thick, that fluid. But that resistance to your motion through a fluid, whether it's a gas or a liquid, that's a drag force, okay? So, for example, air resistance. For example, air resistance is a drag force. You can also call it F air resistance if you so choose. Friction. We're going to be talking a lot about friction in this class. That is electromagnetic. We are going to focus primarily on sliding friction, all right? So when things slide against one another. Now, friction can take other forms, but we're going to focus again on sliding objects. Have you ever noticed, if you're trying to push a really heavy box across the floor, that it's harder to get the box to start moving, to get it to budge in the first place, and then it's easier to keep it moving once it's moving? That's totally true. That's totally true. So we split friction. Remember, this is all about sliding objects. We split friction into static friction. Static friction, the word static is just another word for stationary. That's where stationary they come the same prefix, right? Something that's not moving, static friction. So you have static friction. It's not yet moving relative to the surface. And then you have kinetic friction. Kinetic friction is another word for sliding. All right, kinetic means moving, but we're specifically talking about sliding. I actually prefer to call it sliding friction, but the problem is they both start with S. And so I'm going to use a lowercase f for friction and an S for static, a lowercase f for friction and a K for kinetic. All right. Static friction, again, that's the friction you have to overcome to get something to start moving. Kinetic friction is the friction once it's moving, you need to push against to keep it moving. Okay. Next one. I'm going to stay with blue because I think the green is kind of light and hard to see. Next one is a hard one to grasp at first. It's called the normal force. And I'm going to use a lowercase n for that. You could also use an F subscript n. I'm going to use a lowercase n. The normal force is a supporting force, all right? This, my computer is taking this video. It's resting on a chair. The chair is providing a supporting force. That's why the computer is not falling towards the floor, which would be considered bad. Your chair that's supporting you right now is a supporting force. It's called a normal force. If you can think of any force that's supporting something, the force of a surface supporting something, then that's a normal force. It doesn't have to be straight up. If you had something like a ramp, and you put something on a ramp, if we're in class, I'll demo this, a very exciting physics demo. Well, then the normal force would be provided 90 degrees to the ramp, okay? So let's say this is like something just resting, a box resting on a ramp, all right? This is your ramp. This is the box. The normal force is the force of the ramp on the box. It's always perpendicular to the surface. The word normal, this is something that isn't used too often anymore in math, but it's actually a math word. It's a math term that means 90 degrees, perpendicular. And it's just the perpendicular supporting force of a surface. The perpendicular supporting force of a surface. Again, I'm going to use a lowercase n for that. You could also use an F subscript n, as I said. I'm going to show you some more stuff on that in class when I'm here. And then the last one I'm going to talk about right now, what about a pushing force? If you're just pushing on something, like you're trying to push your chair someplace, I'm trying to push the textbook, I am going to call that an applied force. Applied force. What's an applied force? I'm using F subscript A for force applied. Applied force is just some pushing force. I'm pushing I'm pushing my son in the swing. I'm pushing my textbook across the table. Okay, that's some sort of pushing force. This is not an exhaustive list. There are zillions of examples of this stuff. If you have an airplane that's flying through the air, you have a lift force. I call that F lift. That's electromagnetic. So electromagnetism shows up in all sorts of different ways. This is just to get us started, okay?